Hello everybody and welcome to this new section 4.2 areas under a curve, so this is a really important section. Every section is important, but I just wanted to have a good time with art and with this section actually, and the next section is what got me started in calculus. Really appreciate just shapes and space and how they look like in an empty vacuum space. But yeah, let's start with the basics. This is areas under a curve, and remember, we know how to take areas of a rectangle, square, and any polygon that is regular. Any regular polygons, we find regular figures, and we know how to take the area, and we go ahead and attempt to do that. But now when we transfer this into a two-dimensional space on the x and y plane, and we have a curve, the question becomes, how do we find the area of this region defined by the portion that is under the graph, the portion that is above the x-axis, and from a vertical line x equals a to a vertical line x equals b. If you notice, we don't have an exact shape for this particular shape that was just formed, so we resort to calculus and limits and summations and this amazing stuff. So let's do one of the problems. So you like my art? Yeah. I'm actually starting to have more fun creating these videos, incorporating some art, some of my quirky personality a little bit, and some humor, and I hope that you guys do have a good laugh. If you do have a laugh throughout here, one of my students said to ask you guys to like the video and share it and subscribe, so go ahead and do that right now. Oh wait, I'll give you 3 seconds. Hurry up, the bell's about to ring. And put on your ID and go to your class. Well, you're in my class, so stay here. But now let's do recall some really important information. Hey, stop scratching. No scratching on my couch. Hey, there you go. Get off the couch. All right, good. Sorry about that. Recall that the left endpoint. So if we take any region and we have the left endpoint and the right endpoint, this is delta x. And remember, depending where we started our a, how many delta x's have we moved? If this was 0, now this is a, well, we move a plus how many delta x's, and that's how you start determining the left and the right endpoint of your rectangles that you're going to be evaluating for the height. So we need to understand something before we move on. We need to understand that from the left endpoint and the right endpoint, what is the relationship between concavity, and whether are we asking for an underestimate or an overestimate, and which one gives us which. Does me taking the summation from the left endpoint give me an overestimate or an underestimate, and vice versa for the right endpoint? And the answer is, there is no simple answer. You do need to observe. There are certain characteristics that must be met. For example, oh yeah, I have empty space here. Imagine I just have the linear function y equals x, right? And I ask you to find left endpoints let's go from 1 all the way to 2, 3, 4, 5. 5, and I ask you to find left endpoints. Will you do the left endpoint, for this interval? We do the left endpoint, sorry, drawn almost to scale, and for this interval, this left endpoint, right? We notice by using left endpoints, we end up with an underestimate, and notice my graph was increasing. Now, what happens if we use, on the same graph, we use right endpoints? Well, here, I show you what happens. Let's use this pen right here. On this interval, ooh, that's too thick. There you go. On this endpoint, if we use the right endpoint, well, now this becomes my rectangle. Now, if we use the right endpoint, well, on this interval, this is my right endpoint, this is my new rectangle, and vice versa. So if you start noticing, we end up getting an overestimate. All right, that is no bueno. You don't want an overestimate nor an underestimate. You want the actual estimate. Some of you have reached out inquiring about the midpoint, and if you notice, the midpoint will reduce. Notice how much distance is either being overestimated or how much distance is being underestimated. Notice what happens if I try to do something equal with midpoint. Let's see, can I get rid of this? See, awesome. Síganme. If we do the midpoint on this interval, then we right? So the way that the midpoint works is you take your left endpoint, your right endpoint, you're subtracting, and you get this total distance, and then you divide it by 2, and then you add it to this one, so you know exactly where your midpoint is. Then you go all the way up and you evaluate f of x, whatever that number was here. All right, the midpoint reduces this total area that it would be overestimate or underestimate is reduced by the midpoint by half. So we need to start noticing what happens. So and now it'll reverse if we see what happens if it's decreasing. For decreasing, just do a random rectangle decreasing. Let me go up. Oh, it'll meet there, it'll meet there. Okay, if I'm gonna use the left endpoint, well then I just go here until this one is, and then just go to the right. That is my left endpoint. If I'm gonna be using a right endpoint, well then let me see. If I go up, then let me go to the, you see, so a left endpoint in this case ended up with a left endpoint. All right, it ended up with an overestimate, and the right endpoint ended up with an underestimate. All right, so we need to start using what's happening when my function is decreasing. All right, and now notice what happens. Does it hold true when we have concavity? If something is concave down, right? Just notice if I draw a why use a drawing when I could just concave down. If I use a left endpoint, I'm gonna get an underestimate. Is it? Well, no, look, it's increasing, sure, but what happens here when my function is decreasing? What am I going to get? If I use the left endpoint, I'm gonna get an overestimate. All right, so now like you need to be careful, and vice versa now. I'm loving this versatility. Oh, this is a really nice shape. Love it, love it, love it. Anybody knows what that is called, that shape? And anybody has seen it in art or somewhere else, or a merchandise? Oh, damn, the Latino teacher. Oh, this could be a face. There you go. Circle, circle, one little circle, two little circles, three little circles, one little circle, two little circles, three little circles. Notice if I do a left endpoint and my function is decreasing, I end up with an overestimate. If I do a left endpoint and my function is increasing, I get an underestimate. So just play with that, honestly. Just grab your notebook and your pencil and just keep drawing. Get creative, add some gradients, some shading. It's nice. Just let your mind wander off mathematically. It's really nice when you allow yourself to do that. And everybody can do it. So go ahead and do that. Well, let's go back now that I hope that is a little bit more clear. No, I was not even recording. Here I'm giving this amazing lecture, Parker, not even recording. Okay, or am I recording?